All right, we're going to look at some examples now. So this one, we want to take the integral from negative infinity to 0 of this. So first step, write it as a limit as some other variable like t goes to negative infinity. I forgot the negative there. And then we're replacing that negative infinity with that variable in our integral. Next, we got to figure out how are we going to find the antiderivative here. With those being multiplied, it's not just as simple as finding the antiderivative. Your brain should be thinking, okay, this is a substitution or integration by parts problem. This one looks like an integration by parts one. So our selection for u, we don't have a log, we don't have an inverse trig, we do have a polynomial, so that would be our choice for u, derivative being 1. The rest of this then is our dv, and antiderivative here, that's an easy one, that's e to the x. So now we want to write this out as an integration by parts. So we got limit, so t goes to negative infinity of uv, so x e to the x evaluated at both 0 and t, minus the integral at those same limits of v du, which is e to the x dx. We can now do that integral pretty easily, the one remaining there. And now antiderivative of e to the x is just e to the x here, evaluated at 0 and t. So now we're putting in 0 and t and seeing what we get. So this one, we are going to get 0. If we plug 0 in there, 0 times e to the 0 is just 0. 0 times anything 0. Minus, if we plug t in, it's t e to the t. Minus the other one, e to the 0 is 1. Minus e to the t. Okay, so now next here we want to keep evaluating. I'm going to split this up because it'll be a little bit easier to see, I think, for you. 0 minus this is just going to be negative t e to the t. And then I'm going to distribute this negative sign here. So that's negative 1 plus e to the t. And I'm going to write this as a separate limit over here. Now this one on the right here, this limit, we should be able to find this one pretty easily. What is e to the t going to do as we go to negative infinity? That's a exponential graph. E to the t is an exponential graph. Looks like that. So as we go towards the negative side, what's this approaching as we go this way? You can see it's definitely 0 here. So this side's just going to evaluate to negative 1 plus 0 or negative 1. This one on the left, a little bit more difficult. If we put negative infinity in there, you got the opposite of negative infinity, which would be infinity here. E to the t, as we just saw, as you approach negative infinity, that's going to approach 0. We got 0 times infinity. That's not good because that's one of those indeterminate forms. And so if you're doing a limit that has an indeterminate form, we have to go back to our good old L'Hopital's rule in order to evaluate that. But in order to do L'Hopital's rule, we need to write this in fractional form. So I'm going to keep this limit going here. We need to write that as a fraction. I think moving the e to the t down is easiest because then we can just make that exponent now negative. So what we're going to do now is apply L'Hopital's rule to this to see what we get. So we're going to apply L'Hopital's, meaning we're going to take derivative of both the top and bottom. Derivative of the top is negative 1. Derivative of the bottom, we have to use chain rule there, so it'd be e to the negative t, but derivative of negative t would be a negative 1. So that we got that, and we still got this minus 1 out here. Now if we put negative infinity in there, this is going to be, I'm going to double, let's double slash, we got the 2 negatives here, so it'll just turn positive. So it'll just be 1 over e, and then we got negative of opposite of negative infinity, which would be positive infinity there. So what is e to the infinity going to approach? Well, that's just a giant number. So we got 1 over infinity, which we know as if you take 1 divided by a large number, that's 0. So 0 minus 1 is negative 1. So the answer to this is exactly negative 1. This is the one that is convergent. Reason is, if you look at the graph here, if we graph this one out, enter this one in here, you got original graph was x, e to the x. I'm going to graph this one with our decimal graph here, number 4, so you can see it a little bit. The exact area from negative infinity is 0, so we're talking right in here. You can see it's under the x-axis, so it should be negative. That exact area as it approaches 0, or negative infinity, should be exactly negative 1. All right, let's look at another one here. Next one, evaluate this one from negative infinity to infinity. So here, if you got infinity on both, we want to pick something in the middle that we can split this up into 2. So I'm going to graph this one out here quick. We got 1 over 1 plus x squared. Graphing this out. Here's the graph. All right, we can see on this graph that looks something like that. We're trying to find what's the exact area all the way from negative infinity all through here, all the way out to positive infinity there. Does it have a convergent finite area, or is it infinity? Well, let's split that right at 0 then. So we're going to split this up into 2 integrals, one being from negative infinity to 0 of this function, and the second one then being from 0 to infinity. This should be equivalent to what we have on top. All we did was change it by chopping it in half here. All right, so next now we want to do this as limits here. So we got limit as t goes to negative infinity for this first one. Replace that. On our second one here, we're also doing a limit, but this one's as we go to positive infinity, and we're replacing that with the variable here. Next, we got to find antiderivative. This is one hopefully you kind of recognize now after doing these for a while. This is one of those inverse trig ones. Antiderivative, that is inverse tangent. So we got our antiderivative here is going to be inverse tangent, evaluated at 0 and t. Same thing with the second one. This one's good. Antiderivative is also inverse tangent, evaluated at t and 0. So now we got to evaluate these. So if we plug in 0, we're going to have to figure out what's inverse tan of 0 minus what we get when we do inverse tan of t. Plus the other one looks pretty similar here. But we got inverse tangent t minus inverse tan of 0. So now let's figure out what those are. First one, so to evaluate that inverse tan of 0, you can think of like unit circle here. Any point on here we know is a cosine value of the angle and a sine value of the angle. We're trying to figure out where's tangent of an angle equal to 0 here. So this would probably be easier if we think of it in terms of sine and cosine. We know tangent's the same as sine over cosine. So when is that going to equal 0? This will equal 0 where sine equals 0, because if you got 0 divided by something, that's going to be 0. So where does sine equal 0? Where's the y value equal 0 on here? Should be right here. That's the point 1, 0. That's our sine value equaling 0. So inverse tan of 0 should be 0. You can jump on calculator to verify. If you do inverse tan of 0, should come out to be 0. All right, so we know that's 0. So now this just turns into what's the limit as t approaches negative infinity for the opposite of tangent inverse at t, plus now this other one's limit as t goes to positive infinity, and again that one's going to evaluate to 0, so we're just looking at tangent inverse of t. So what are these approaching as we go to infinity here? This one probably be easiest to kind of look at graph of, so let's graph out inverse tangent here. Make sure you're in radians for this. So if we graph it out, here's the graph. What is this approaching as we go to negative infinity or positive infinity? You can trace along here to maybe start looking at what those values. That might take you a while. It's probably easier if you jump to the table on here and look at what the table is going to be for big values. Table settings might be a way to jump up. Let's start this at, let's do the positive one first. Let's look at like 5,000. So what value do we get here? You can see it's 1.5708. Well, what's that? I mean, we could write the decimal approximation, but that's actually something you kind of think, okay, it's part of a circle. What angle is that going to be here? If you look at 1.508, that is associated here with pi. If you do pi and take half of it, you can see it's the same value there that's approaching. So this is this positive one here out here that's approaching pi over 2. The other one, as you approach negative infinity, if you look at this graph, is approaching the same value but on the negative side. So this one's approaching negative pi over 2, but we have that negative sign here we got to bring with it and drop down. And so we get basically pi over 2 plus pi over 2, which would be pi. The exact area back here under our graph right up here, that exact area from negative infinity to infinity is pi, which is kind of weird that it comes out to be exactly pi there.